Okay, so today we're going to be talking about slope and using slope to identify parallel and perpendicular lines. So by the end of today, we're hoping that you can calculate the slope of lines yourself and use those slopes to identify whether lines are parallel or perpendicular. A lot of this should be review. You should have covered this in both 6th and 7th grade. So we're going to move pretty quick through this. And like always, shoot me an email if you have questions at the end. So our two vocab terms for this are slope and rate of change. So slope is the measure of steepness of a line. So this is commonly denoted as rise over run. I'm sure you guys have seen that before. So rise over run. Let's try to write it where we have room. Hot start. Rise over run equals slope. And then rate of change is just the speed at which a variable changes over time. So like, I think of speed when I think of rate of change. So miles an hour. So how many miles are you going to go in a hour? So if you're going 60 miles, that means you will travel 60 miles per hour. You are going to travel 60 miles for every 1 hour. Rate of changes are often graphed too, just something to keep in mind. All right, so key concept, slope of a line. In a coordinate grid, the slope of a line is the ratio of change along the y-axis to the change along the x-axis between any 2 points on the line. The slope m is almost always used to show slope. It's one of those random math letters that I don't know where they got it from, but it's always m. Of a line containing 2 points with coordinates x1, y1, and x2, y2 is given by the formula m equals y2 minus y1 over x2 minus x1, where x1 does not equal x2. Which we'll get to that in a little bit, but big picture on this is if the bottom is 0, so like if your rise is, let's just say your rise is 12, let's choose a smaller number. Let's say your rise is 4 and your run is 0, meaning that your line is going straight up and down, like this green line here. Your slope is going to end up being undefined. And the reason for this is if you divide a number by 0, you can't do it. It's fake math. And we don't do fake math in here. So if you took your calculator and you punched in 4 divided by 0, it'll give you an error. And that's because you can't divide those numbers. But that's a quick way, because I always got mixed up with whether a vertical line is undefined or whether a horizontal line is undefined. A horizontal line is 0, and my quick way to remember that is if we do like 0 divided by 4, then if we punch that in the calculator, 0 divided by 4, we get 0. So our slope would be 0. Whereas if we did 4 divided by 0, it's an error, which would be undefined. So I just use my calculator as a quick check for my horizontal versus vertical slopes. Okay, so our first question here is to find the slope of this line. So anytime they give you a graph, there's a really quick way to do this, and that's just solely counting. So we know that our slope is rise over run. And so we always work from left to right. So as we can see, as we move from left to right, our slope is going down. So we're going to calculate our rise, which is actually dropping. And that's going to be 1. Let's do it this way. Let's get red. 1, 2, 3, 4, 5, 6, 7, 8. So our rise is going to be -8 since we're dropping. And then our run is going to be 1, 2. And our run is going to be positive because we're moving from left to right. So our slope ends up being -8/2, which we can simplify to m equals -4 for our final slope. The other way you can do this is you can actually write out our points. So we could say, why did it choose that? So we could write point S is going to be -3, comma 3, 6, 7. -3, comma 7. And then point T is going to be -1, comma -1. So we could use those 2 points to plug into our formula, which is x1, I'm sorry, I'm just messing up all over the place today, which is y1 minus y2 over x1 minus x2. So equals slope. So we could use those 2 points to calculate that, which I would just say my -1s are going to be x1, y1, and then -3 is going to be my x2, 7 is going to be my y2. So I would just plug in -1 minus 7 over -1 minus -3, which would be -8 over 2, which would equal -4. So my slope would still be -4 doing it that way. But personally, anytime I see a graph, I prefer to just count it. But it's totally up to you. Okay, so now we have a vertical line. Anytime we have a vertical line, our slope is going to be undefined, which there's a nice graphic later that I would put in your notes. Don't feel like you need to put it in your notes right now. But the reason for this, again, is because our slope equals rise over run. And our rise here is from point Q to point P, it goes up 7. And then our run, our left to right movement, is 0. So our slope is 7 over 0, which we can't actually divide that and simplify it because it's just not real. It's fake math. So equals fake math, frowny face, also known as undefined. All right? So this one we can actually do. So once again, I prefer to count these. I'll do it both ways just in case you prefer the other way. My words are just a struggle today. So I'm going to do it in my opinion, the longer way, using the points first. And then, hang on one second, I'm getting a call. So we're just going to run through the video with this. What's up? At 2? Okay. I will, I'm making a video for math right now, then I'll run over. Alright, see you in a bit. Bye. Alright, sorry about that. But that's the way we get it when we make videos on the weekend. So we're just rolling with it. So anyway, point G, the coordinates for point G are -2, -5, and then the points for F are going to be 6, 2. So I'm going to label these x1, y1, then x2, y2. So once again, our formula is m equals y1 minus y2 over x1 minus x2. So when we plug in our values, we get m equals -5 minus 2 and -2 minus 6. And when we simplify that, so -5 minus 2 is -7 over -2 minus 6 is -8. So we can simplify that out further and get rid of the negative sign. So our final slope is 7/8. Now, the other way, and my preferred way to do it, of course, is to calculate the rise over run. And we do that kind of by making a little triangle. So I'm going to count my rise first, which is 1, 2, 3, 4, 5. Oh. Nope. Why is that not? 6, 7. So my rise, and of course we're moving from left to right, so it is going up. My rise is going to be 7, and then my run is going to be 1, 2, 3, 4, 5, 6, 7, 8. So my run is going to be 8, moving from left to right, so it is also positive. So my rise is 7, my run is 8, so my slope is 7/8. And that checks out. We got both of the answers is the same, so we're all good and happy. Now we have a horizontal line, so going straight across from left to right. And in this case, our rise is nothing because it doesn't move up and down at all. So my rise is 0, then my run is, well, in this case, it's 1, 2, 3, 4, 5, 6, 7, 8. So 0 divided by anything other than 0, of course, which I think is up for debate mathematically. Some people would say 0 divided by 0 would be 1 because any number over itself is 1. Some people say anything divided by 0 is 0 or is undefined. So it's a hot debate in the math world. You know, a lot of us mathematicians debate it, and you know, a lot of like 99.9% of 8th graders don't care at all. So for our purposes, we're just going to say anything that's horizontal has a slope of 0. And so 0 divided by anything is 0. So our final slope would just be 0. Because when we simplify 0 divided by 8, we get 0, of course. So in general, any horizontal line going to be a slope of 0, which, like I said, there's a nice graphic a little bit later on, like in 2 slides. Okay, so this is the last slope we're going to do. Well, the last calculating slope via graph we're going to do. I'm not going to do it the long way this time because I don't want to make this video ridiculously long. So once again, I'm going to count these out. As we move from left to right, our line goes down. So our rise is going to be 1, 2, 3. And it's going down, so I'm going to say -3. And then as we move from left to right, I'm going to count 1, 2, 3, 4, 5. And +5 because we're moving from left to right. So my final slope, m rise over run. And then my rise was -3. Then my run was 5. So I'm going to say that's our final answer because -3 over 5 can't be simplified any further. Now, you could write it as a decimal if you so prefer, -0.6. Personally, I like to leave it as a fraction because when we're working with graphs, we can actually just count it. Instead of saying every one square we go right, we have to go up 0.6. We can say every 5 to the right, we go down 3. That's just my personal preference, but you can write it either way, and that's perfectly fine. Okay, so I would write this little figure into your notes. Positive slope kind of slants up as we go left to right. Negative slope slants down as we go left to right. Zero slope would be a horizontal line straight across, and then an undefined slope is going to be a vertical line. We're going to move on from this, but if you want to put this in your notes, go ahead and pause the video and do so, and we are going to move on. So we have one kind of real world problem that I want to work through just to show you guys how slope can be used to calculate future estimations. Once again, I'm sure you guys have done this before also, but this is just going to be kind of a refresher. So our problem says between 1994 and 2000, the number of cellular telephone subscribers increased by an average rate of 14.2 million per year. So that would be our rate of change because it's a number per time. So in this case, it's 14.2 million per year. In 2000, the total subscribers were 109.5 million. If the number of, let's go ahead and underline that. That's probably important information. If the number of subscribers increases at the same rate, how many subscribers will there be in 2010? Okay, so important information. In 2000, there were 109.5 million. I'm just going to say sub. So 109.5 million subscribers. And then it's increasing at 14.2 mil per year. So in 10 years, we can estimate, so if this is 14.2 per 1 year, if we make this 10 years, we can estimate that this top number would be 140.2 million. So they're going to have 140.2 million new subscribers in the next in the next 10 years. So if we take this number and add it to our starting number, we can guesstimate that they're going to have about 149.7 million subscribers in 2010. So when we go to our answers, 249.7 million subscribers. When we go to our answers, that's not one of the choices, but if we notice, all of these are about. So we just need to be kind of in the ballpark. And the closest one to our answer that we got is going to be this 251.5 million. So that would be how you do that. So you can take your rate of change, which was 14.2 million a year, and multiply it times however many years you're trying to calculate, and then add it to your initial value. So now we're into parallel lines and perpendicular lines, and dealing with the slopes associated with those. So whenever we have slopes of parallel lines, since they run along the same path and they're never going to cross, the slopes of parallel lines are always the same. So if we had two parallel lines and one of their slopes was 4, that means both of their slopes are going to be 4. I feel like that one's pretty straightforward. So anytime you have parallel lines, their slopes are going to be the same. Now, perpendicular lines, their slopes are going to be a little bit different. So they're going to be the exact opposite. So if we had a slope of 4, let's say, so this line here has a slope of 4, this line M. For the perpendicular line, we have to completely reverse it. So 4 could be written as 4 over 1. So what we need to do is flip it and then make it negative. So for it to be parallel, or I'm sorry, for it to be perpendicular, we would have to have a slope of -1/4, which is what this line P is. You can see they cross at a 90-degree angle. So this is kind of just a rote memorization thing. You have to know that perpendicular lines have the opposite inverse slope. So you flip it and you add the negative to it. I would 100% put that in my notes. You just have to memorize it. It's one of those things that we have to memorize, which I don't love, but just make sure it's in your notes so you have it come test and quiz time. Okay, so problems that you'll see based on this fact, you might see something like determine whether AB and CD are parallel, perpendicular, or neither, using the following points. So they give us point A and B, and then they give us point C and D. So we have to calculate the slope of each line and see whether they are perpendicular, parallel, or neither. Maybe they're just intersecting. So first things first, let's calculate the slope of A. I'm going to say x1, y1, x2, y2, and then we're going to plug those in. So y1, -1 minus 5 over -2 minus 4 equals -6 over -6, which equals 1. So our slope for line AB equals 1. Now for CD, we're going to do the same thing. I'm going to say x1, y1, x2, y2, and then we're going to plug those in. So y1, 1 minus -2 over 6 minus 9, which leaves us with 3 over -3, which is the same as -1. So our slope for line CD equals -1. Okay, so looking at these two slopes, they are perpendicular because they are flipped and opposite. So it's easier to see if I write it like this. So AB would equal 1 over 1, and then CD would equal -1 over 1. So looking at this, we can see that if we flipped 1 over 1, it would still be 1 over 1, but then we add that negative in, which makes it the opposite. So that is why these would be perpendicular, because we can flip it and then make it negative, and that's the change that happens between these two. All right. So on this next problem, they want us to graph the line that contains point Q, and point Q is at 5, 1, and that is parallel to line MN. And then they give us the 2 points for line MN. So when you see a problem like this, the first thing you have to do is realize, okay, both of these lines are going to have the same slope. Now, we don't know what that slope is yet, so we have to calculate that. So that takes us to our second step, which is going to be calculating the slope of line MN. So to do this, I'm going to label x1, y1, x2, y2, and then we're going to plug that in. So 4 minus 1 over -2 minus 2, which leaves us with 3 over -4. So our slope is -3/4. Now that we know this is our slope for both lines, -3/4, we have to figure out what another point is for that line that contains Q. So me personally, what I like to do is I like to say, okay, if I was calculating the slope of line Q, then I'm going to say this is my x1, this is my y1. So I would have 1 minus something over 5 minus something else is going to equal negative 3 over 4. And now, based on this, I'm going to kind of cut this equation in two and solve each of them individually. So I'm going to look at the y's and I'm going to look at the x's separately and then make that my second point. So I'll show you what I mean. So if I write this top equation out, I have 1 minus y equals negative 3. Now I can solve this by subtracting 1 from both sides. I'm left with negative y equals negative 4, which I can multiply by negative 1 to get rid of that, times negative 1, get rid of that. So I'm left with y equals 4. Now I'm going to do the same thing with this second equation, which is 5 minus x equals 4. I am going to subtract 5, and then I'm going to have negative x equals negative 1. Then I'm just going to get rid of these negatives since I have 1 on each side, and I'm left with x equals 1. So now that I have my x and my y value, I can write my point, which is going to be 1 comma 4, since it's always written as x comma y. Now, this works, but if we wanted to double check it, we could actually plug these values back in up here, and we could say 1 minus, then our y value, 4 over 5 minus 1. And so what we're left with is negative 3 over 4, which is that initial slope that we had. So it confirms that our new point would be 1 comma 4 to make those lines parallel.